Uh, also, also one more thing. Um, Vaccine. Will we have sort of access to WhatsApp group now, or it will happen a bit later?
What do you mean? You want to have a WhatsApp group with the students or?
Yeah, probably
Yeah, okay.
yes.
As I'll make one, yeah.
Okay, thanks. Okay, guys. So let me gradually start. Um, First of all, like I'm glad to be here, and hopefully, I will be able to give you some. Sorry, sometimes I'm slow in my English. Like, I don't think anyone can change like level of preparations in several lectures. Um, but what I really believe is that the person like himself can do change the level of his preparation in quite short time. So that means that I might be given like 30 lectures in the next couple of months, and it may be not that impactful if you just watch, right? If you just observe what's happening, and instead of that, it may be just a few classes, but if you take much efforts on yourself and you use me just as an assistance, as sort of part of your preparations, but rely more on your motivation, on your plan, and so on. I believe that some substantial changes may happen in quite a short time, in few months. So from this point of view, I want to be not just a lecturer which gives you some rare topics or some very intensive preparations, but rather I want to motivate you and to give some direction for your further preparations, right? So this would be my like ground zero uh, level, or like my basic point of view during the entire preparation. So I'm just helping you to like to have your training session. Um, um, that would be the first thing. The second thing is like first I will give some um, establishing things, like some basic things for our uh, classes. So the things which would be probably um, the main idea or the main guidelines, and then we proceed to the problems, to geometrical problems for today. Mm, So the second thing to mention is that I believe that in most cases, like the one of the main misconceptions which I saw in preparations to Olympiads uh, is that people believe that they sort of must take the more and more complex things, sort of make big jumps in their preparations. And I never saw more harming idea than this. There is also another variation of this idea. Um, it was even a title of a famous song. It's called "I Want It All." Like I want it all, and I want it now. Very motivating song by Queens. But in reality, I never saw more harming thing. So my sincere belief is that the main thing which lets you win competitions or gain the best results you can is mastering the basic things to that level which is not accessible to others, basic things. And you know some not elementary, advanced, and super advanced things. So like, namely in this proportion, like super mastering basics and mastering a bit very advanced things, but also to mention like having several your favorite tools in every area of your professional of your profession, like several favorite tricks, I would say, which you are ready to use in almost any opportunity. So for me, for example, in geometry, that was trigonometrical calculations. Though I appreciated much classical geometry, like I really like the aesthetic appearance of geometry. But speaking of competition, probably in 50% of my solutions, and I was quite good in geometry, like at some year I was like one of the best in Russia, for example. Like in 50% of the cases, I was finishing the solutions just with ugly calculations in trigonometry, though probably I could do that in classical manner, but it was just more effective. So that is almost my part of my faith, mathematical faith, that mastering basics is the key to like any other level of complexity. So that's why I will be focusing not on the particular topics, like not on particular difficult topics in geometry or in mathematics during our trainings, but I will be focused on the progression to that levels. So I will try to touch the entire span of things, like from very basic to very complex, maybe to just complex, so that you can adjust something in basics, you can restructure your basics, and you can follow how it's built up in larger constructions of like more complex topics. So that would be the idea. And probably the third thing to mention, which though is implied from the first one, so the first one that the training is your process mainly, and I'm just assistance. The third thing is that just lectures, they worth almost nothing. Your experience is the main thing. That's why sometimes I will be just giving you a task before explaining, because basically that is what you are training for, right? You come to Olympiad, you have no preliminary knowledge, like what will be there. So I'll be giving you some problems, and I will be expecting that you put much attention to those problems and try to progress as much as possible during some pause, natural pause, which I will suggest you. Like, for example, now I will give you several quite simple problems, and I will give you probably 10-15 minutes to solve them or just to have progress in them, and then we can discuss. And that makes rather much sense to me than just telling you the idea and telling you solutions of those simple problems. Like, you're absolutely capable of understanding, I believe, almost any solution in geometry, but that doesn't mean you can solve any geometry, right? it's quite big difference, understanding and producing by yourself. So I'll be more relying on feedback from you about your progress, and then I can make a strategy, like to which direction we should go further. Probably no big questions could arise by now, but just know that at any moment, if you have any question, you may ask that. Of course, if I'm speaking at that moment, it's better not to interrupt me. You may send that to chat. And also, I believe already you have the possibility to join me, to contact me on WhatsApp. So you feel free just to write me a personal message with the solution, with the question, with anything that I see that as part of our training, part of our infrastructure. Speaking of the problems for now, just one sec. Sure. So you'll have like 5 to 10 minutes probably, like for solving these problems now. They would be quite elementary, though still they may cause some difficulties if you are limited in time. And that is quite an important thing. So I believe that starting from some level, students, like not students, just like those who do mathematics, they are capable of solving almost any problem, say up to of IMO level. The question is, how much time will you need, right? If you need several weeks for that, probably that's too much, like for such purposes. Yeah, so these would be two problems. Just to mention, like the first accent of our training would be angle chasing. I would rather say it would be drawing and angle chasing. And then we move to some more complex things. So as soon as you have the solution, please let me know without writing the solution to any common chat, general chat. So you feel free to send me the solution to WhatsApp. And in the end of the day, that is like what I want to see, that you send me the solutions. But as for now, it's okay just to let me know that you did that. When you did that, like feel free to continue to preparing the solution and sending it to me, probably with a photo to WhatsApp. Also, I expect you not to use any additional resources at least unless it was mentioned, right? So for geometry, definitely I don't suppose that you may use any solvers, even graphing tools are not welcome, actually. Like you may do that if that is part of your normal routine. I know that some students, they really use that professionally, like some graphing tools. So we may discuss that later. But if you are not used to like using graphing tools like GeoGebra or something like that, please don't start right now. Like keep that at least till your free time. And also, I would appreciate if you don't use it to your home task uh, directly. So if you do some drawings, do that by hand.
Andrey, there's a question. Yeah, the which
Mhm.
sides of the trapezoid are parallel?
Uh, Base AD normally means that AD is one of the two parallel sides. Like if we speak of trapezoid. So trapezoid, I don't know, maybe it's sort of specific to Russian, but I understood that it is like uniform. In trapezoid, we have two bases, and those would be exactly the parallel sides. Also, if you solved all the problems or you need some new problems, like more difficult ones, uh, also feel free to let me know, because sometimes the like common speed of like joint speed of the class may be slower than your personal speed in principle or in some particular topic. Sorry, those who will be looking this in recording, like professional training sometimes looks just like this. Somebody is doing something, nothing much exciting is happening, but probably will be able to cut out these pauses, but they are quite important for the process of those who are training right now. Let's have like 5 more minutes to start discussing. So try planning your time, planning your efforts. Maybe not 5, but like 8 minutes. Um, so that it's easier to go by clocks. I also suggest you to share your ideas, like personally as well, in like before the end of the time. So probably in 2-3 minutes. If you don't feel like you're finishing the solution, then take a break and just write down your ideas, what you see, what you think, what you plan to do, and so on. I see this as a strategic training, because when you are very limited in time, you must plan what you'll be doing during the next like 15, 20 minutes, half an hour, 2 hours. Otherwise, you just do as it goes, and that is called hobby, right? It's not professional attitude. So if you didn't if you haven't solved the problem, like at least some of those problems, it is very good time to start writing down your ideas. So I would really appreciate if you if every one of you will share your ideas with me. It would be a bit easier if you do that personally and in written form. Otherwise, it becomes like we spend some more time and a bit more resources in organizing that in class. Normally, some of the people just don't have things to add, because like a couple of their friends already answered something. So it would be rather easier to organize if you share your ideas in written form. Maybe it would be easier to you just to write down and send a photo of what you wrote by hand. If you prefer typing, that is probably even better. You just type your words. If you experience substantial difficulties because of writing in English, please let me know. Because like as I'm giving you like as I saw the lectures in English and as I give you lecture in English, I expect you to like to have like to understand and like being capable of that. But like different things happen. So I definitely want to know if it's troublesome to you to write in English.
Excuse me.
Yep.
Where exactly we would send our notes and solutions? Do we send you them on WhatsApp or on chat here?
Better on WhatsApp, because first of all, it would be troublesome to get to the chat when it's offline, right? Probably it's doable. They have some new options, new like services, but still WhatsApp would be like just as normal conversation. And we can continue then after the class. And yeah, try to organize that as casually as possible so that you don't need to overcome many obstacles to send the solution. The easier it is done to you, the more chances you can do more, right?
Okay, thank you.
Welcome. I will share two more problems with you before starting, before like continue to discussion. So that if you understand at some moment that you perfectly know all of this, then you can just go further. And of course, later on, I will share some PDF with the problems. But you will notice that it is highly affected with what we do and how we do in class. So these would be more complex problems. Now they would have temporary numbering, like temporary 3, temporary 4, but probably they would be not 3 and 4 in the task. They definitely would be not 3 and 4. 3 is just more complex, and it would be already slightly different topic. It would be not about counting angles. It would be about moving some elements of the picture. And problem number 4 would be even more complex. It would be already problem of some IMO. Probably I wouldn't mention the number, like the year of IMO now, so that you have more motivation to do it yourself. So, haven't received any comments as for now. hopefully you are preparing them and will be sending right now. But also I expect you to put at least half of your attention to what I'm telling you, though it may sound very, very basic. What I found training students from like very, very starting level to like IMO competitors, that some of those very basic things, they're oftentimes sort of violated, though they're like, I would say they're absolutely necessary for doing geometry comfortably. I know quite a number of students who say that geometry is a difficult topic to me. And like some of them say that they don't like geometry. Some of them say that it's just not going well. In most of the cases, that is the result of like too much efforts which you need to bring to the problem so that you just start solving the problem. So if you spend like too much energy just to start, it's of course becomes very tiring, not mentioning that it just takes more time, so it remains it remains you with less chances to go to the final result. So the very first thing in doing any mathematical problem would be, of course, reading. Like here, those who will be online, I would ask you to do a screenshot of the problems so that you can keep track of what I'm telling, and also to have access to the problems like immediately. So if speaking of solving any mathematical problem, we start like from what we start solving the problem. Solving a problem. We start from very uniform and absolutely same steps or stages of the process. First, we need to get the task somehow, right? Normally, we solve not the problem which we came up to. Like that would be not our own problem which we start solving. So first, we need to learn some information about that new situation, which we'll be calling the problem. So we start from reading normally. Of course, sometimes some friend or our colleague or teacher may tell us orally, but in principle, that would be just mimicking this reading part. Why mimicking? Why that's not the main source of communication, like speaking? Because what I will not emphasize, but which I will be having in background, would be some very, like, even more basic ideas about mathematics, which are part of my mathematical constitution, I would say. So one of the very, very, very basic for me is that mathematics is something which is done or which is used for having reliable results. Part of this process is that, like, for having reliable results, we need to have instant, like, permanent access to the task, and we should have permanent access to the presented result. For example, if we solve the problem in our head and we didn't write it down, I don't account that as a solution, even though it may be a solution, but we have no means to check that. And that means that it doesn't satisfy one of the very basic mathematical points or positions, that the information must be done in a reliable way, in such a way that it may be checked, verified with professionals of the area. So if we cannot verify, we cannot guarantee that that was mathematically right. And that is why I don't account these means of sharing information or interchange of information being fully mathematical. So if speaking of modern traditions of mathematics, modern rules of mathematics, then like we get reliable mathematical information just by reading, not by oral conversation. I will give some more comments on this, but like that must be quite straightforward about reading. If speaking generally of solving a problem, next part would be modeling. So when we get information from the text, basically on, I would say, cognitive level, we have just a bunch of words, some notations, and like maybe some formulas. And we have this transparent for professionals step when we do model the situation in the very basic terms, very close to the text. Though, if we have some complicated situation, and you may immediately recall some of your friends which are not so professional and which try solving some combinatorial problem with, I would say, complex task. For example, the problem which sometimes is referred as Einstein problem, where like there are several guys who live on some street, some of them smoke pipe, some of them like drink coffee, they have houses of several colors. So for professionals, that is almost not a problem. Like that would be like if you understand the problem which I mean, like quite famous and like for general public. So like for professionals, that would be some simple, maybe not very straightforward, but still simple combinatorial task. So you have several conditions. You must untwist the text. You should organize the information a bit, and you have the unique answer. That is like quite straightforward. But for those who are not professional, just the amount of text becomes a big obstacle just because they cannot make and maintain good model. That is the problem. So that is how we can know that this question sometimes is very important. Like how do we model? And actually in geometry, it becomes even more important. So in geometry, which would be like our main concern during this class and some upcoming classes, in geometry, that oftentimes means drawing. And there would be several absolutely non-trivial recommendations or even rules how to draw properly so that you solve geometry with more chances. And then when we do the modeling, we actually study, like here we actually, like there would be several important intermediate steps or containing steps in the modeling, which are also oftentimes just skipped, not discussed. And that means that we do that intuitively oftentimes. And that means that if we do have troubles here, and we're doing that intuitively, like the fact that we have a trouble means that our intuition doesn't work in this situation for some reason. It already didn't work, right? It haven't worked in this situation. And then it is very dangerous situation for a professional because like if you have no plan B here, some technique how to overcome this trouble, then relying purely on your intuition results in finding that difficult case when your intuition doesn't work and just stucking at that point for a long time. Sometimes you will overcome that, sometimes you will not. The thing is that you don't control that. And that is not a safe position, of course. So that's why sometimes giving a bit more instruction in basic things or having clear understanding of some additional instructions may be a good idea. So modeling normally would be recognizing the objects of the situation. Like problem for me in general would be just mathematically specified situation. So we have a description of the situation and we understand that we must understand the situation or the data in mathematical tradition, and we must provide the results in mathematical tradition. So I will be sometimes saying situation instead of saying problem. So this would be recognizing the objects of the situation. Then that would be properties of the objects. For example, one of the important things to recognize would be type of an object. And that would be sometimes an issue in combinatorics. So if we don't realize what is the type of the object, is that a permutation, for example, or that would be some choice with repetitions, or that would be some other basic thing, basic type of structure, we may mismatch the question in principle. So the question is asked, we believe that we answer something, but we have some delusional picture of the situation because we misrecognized the type of the objects. And that would be one of the basic reasons for miscalculating. But here we will have, of course, different sort of issues in geometry. Like, and the third would be, so we have just three main sections of this modeling process. So we must recognize objects, we must recognize properties, and we must recognize relations between the objects. So the idea is that we don't have some substantially large and complex theory about how to model. We may have different complex tricks in modeling in some areas on mathematics, but in principle, mathematical modeling is just recognizing these three clusters of information. And always the question of the problem would be somewhere between these three types of information. So yeah. And just then, so when we done these things, we start like we proceed with the mathematical part of solving. So before this, it was even not mathematics, though I would say that probably 80% of not solving a problem cases would be with issues in these 2 points. So like people even haven't stepped inside of the situation. So like being a professional means that you do these steps properly in like 99% of the cases when you solve mathematics. So then you have some real mathematics here. The thing is that solving geometry like because of not recognizing these very basic things, though already in professional interpretation, people oftentimes think that doing geometry is difficult because there would be, I don't know. Actually, like as a person who does these things, like it's sometimes it's even not that simple to like to like to recognize what were the issues not to do that, right? Not to solve that. So like turns out that solving many not very complex geometrical problems is just doing properly the first two points here and having just 1-2 steps on the like in the point 3, like almost having no mathematics there. So that is my purpose, to make this image of geometry to you. I heard that geometry is sort of troublesome topic for many of you. So I believe that may be some new point of view on this, because like normally those who have such attitude to geometry, like they do geometry without suffering, I would say. So let's try to observe how these like common sense, it may sound as common sense principles affect the process of solving. Here I want to give some special warning, like so that you don't recognize these points as totally common sense, because for example, for modeling and for like more broad area of discussion, it's not true to say that these 3 points would be covering all possible situations. For example, in broader topics, we have such category as our attitude to what's happening, and we have no space, no room for such category in mathematical problems. So that means that this would be specific to mathematics, and like probably specific to exact sciences. So though they sound very elementary and very common sense, common language, we still use them professionally, mathematically. So now let's try apply those principles, and let's specify a bit more how it is better to do this drawing part or modeling part in geometry. And for this, we will take these 2 first problems as the exact like direct examples. So we start from reading, and I will do that for one or couple of times as I do that myself. Just before I do that, before I start doing that, like I actually want to do a technical pause for a minute. I need to change my location. So you have some short extra time, maybe a minute or 2, while I'm transiting from my garden to my office. 1, 2, 3. Can you hear me well?
Yes.
Okay. So we continue. And we continue with the first problem, trying to make some use of this reading and modeling parts of the plan, not just as intuitive actions. Just one second. Okay. So like reading may sound very straightforward, but somehow people do that in not very straightforward manner. So first thing to mention, maybe I even will do some some records reading, but those would be very elementary. It's just as I'm writing all the basics here. So like to have the full picture, I will do some remarks here, probably if we have something good enough, like important enough. But the very first thing is very important, though people skip that. Reading sentence by sentence. One unit of information in most of the languages would be stored. So this would be not lesson of mathematics in this part. It would be something different. As I mentioned here, mathematics start just from here mostly. Here on the modeling step, we have some elements of mathematics when we do correspond to or relate to the current situation, some elements of mathematical, I don't know, database, right? We decide that, okay, 17 people in this situation, 17 is a positive integer number. So we relate the object of the situation or the property of the situation with mathematical term, with mathematical, what I would say, substance, like number 17, right? But in principle, real math starts later. So that would be just like relating to math. So here, we say about some maybe cognitive things. So we must not jump forward until we studied what is which information is provided in one sentence. And speaking, if we speak of professional dealing with this, recognizing these three clusters of information, these three types of information. So until we finish understanding of the sentence, we don't go forward. We, of course, in real situation may jump forward if we didn't understand, in order to relate some phrases, some terms, which we are not very familiar, to some other things in the text, so that we can finally identify what did they mean by that term. But then immediately we come back to the to the place where we were reading and we continue. Otherwise, our construction of our model may have very fragile foundation. You can imagine if you try to build some skyscraper, like some very heavy, very tall, very, I don't know, exquisite in construction thing. If it has failed foundation, basement, which has some cracks and holes, the building will not stand for a long time, right? So in mathematics, that means that your understanding of the problem will be not sufficient for solving. So here, technically, that means that I go through the sentences as many times, again and again, as I need to realize the sentence before I proceed to the next sentence. So here on the base AD of trapezoid ABCD, so we have this trapezoid. Let's have another slide here. So we have trapezoid ABCD. We shouldn't do it very special, because then our drawing, if, for example, if I draw some equilateral trapezoid with equal lateral sides, after drawing, I may have some incorrect image of the situation. So for these purposes, we rather should use very general situation without any specific specialties. So we have base AD, trapezoid ABCD. Point E is taken such that AE on the base a point E such that AE equals to BC. So I draw this point E, and I immediately actually denote. So what I did here, when I put E, I identify the object, the point name E, right? That would be just the first cluster of this information, recognizing the objects. If I just recognize the objects here, then I miss their properties and relations. So to respect at least the properties, I immediately denote the equal sides, right? So denoting equal sides then gets more reason, because in reality it becomes identifying the instances of second category of data, identifying properties of the object, of the objects. It's not just auxiliary thing. It's really important thing in geometry. Maybe more important than you imagined before. Okay, so that is it for now for the first sentence. Segments CA and CE, CA and CE. I have the objects mentioned, so I must model them. Here I understand that this is not equal, so I will change it in this computer manner. If I draw that on scratch paper, I do first drafted picture. No, actually, you know what? Let me do that in the manner I would do on paper, because on competition you don't have this opportunity to change with Ctrl+C, Ctrl+V, or like with any computer features. So this would be the missing object CE mentioned here. Intersect diagonal BD at points O and P respectively. So here no additional properties would be mentioned. Prove that if BO equals PD, so again I denote BO equals PD, and some people here, like another strategical mistake sometimes happen. People really do underestimate the importance of these notations for solving geometry. And all I tell here is for solving, not just to doing that in some wise manner, in some attractive manner, in some, I don't know, fashionable manner. I do that so that in the end of the process, I can say that my problem was solved, that I have my solution of this. So from this point of view, if just following the guideline of denoting equal segments, students do use same notations oftentimes. like this side it was equal to this side, and this segment equals to this segment. They just denote like this and like stay happy because they fulfilled the instruction. But actually that is like just faking the process and making bad present for himself. So we should have different notations, right? We have different equalities here. We should have opportunity to see them, that they are different. So we make another notation for this, and we must understand that is another misconception. So people just do write AD equals squared equals to BC squared, or they even don't write that oftentimes. But what I emphasize is that we must have the model here. Our model for geometry is drawing, is our picture. So we must have some interpretation of this, which is just a phrase which have shorter version. Otherwise, like if we discuss this problem like 400 years ago or so, we probably would discuss that without these formulas. We will discuss that in words, but still like doing the same problem would be possible. So these formulas, they're first of all just shortcut for some text. And second, this would be some condition which we better understand somehow on the picture, because that would be relating this task to what we understand about the problem, right? Purpose of the model so that we have image of the situation. So if we cannot relate the formula to our interpretation of the situation, we are just like in trouble. So what I do here for myself, for example, first of all, I do denote that this is something under question. So this is not an equality to use, this is equality to verify. And second, I try relating these objects to the picture, to the objects on the picture. So AD would be here. BC would be, of course, here. AD times BC would be, of course, like there as well. Is it correct? Just one sec. I will double check the task. Yeah, like, yeah. Yeah, I just did some mechanical translation, so I will, I was double checking something. Okay. So looks like we did it, right? We did a drawing, but my claim is that no, like this is exactly where those who don't solve geometry finish, and that is why they don't solve the geometry. What also we have here? So we going like following this instruction, we recognize the objects. Probably we recognized all the objects. Like I don't see any additional objects mentioned here and not respected here. Also, we must recognize the properties of the objects. So at least the properties mentioned in the task, they were also denoted here, right? So we have equal segments, we have trapezoid. Like for trapezoid, it's a bit questionable. So properties of trapezoid probably are not respected on the picture. But also like properties of trapezoid, that would be more relations between parallel bases AD and BC. That is what I want to emphasize. So what is not to what we paid no attention here, to relations. So the only real relation here which I can see is that we have two parallel lines, like the basis of the trapezoid, and there would be a special instruction for it. So relations on a drawing. So relations on a drawing would be like the best way to respect them on the drawing is not writing down that this is a trapezoid. That shows nothing actually. That would be finding for every type of relation, for instance, for the straight lines to be parallel, some language of notations which specify that on the picture. So, for example, like saying that the lines are parallel. No, saying that the lines are intersecting, which is also a relation. So we actually have more relations here. We know that BD is intersecting AC. So the way we denote the relation is that we denote the intersection point O. But for parallel lines, we have no such opportunity, right? We don't have opportunity to denote the intersection point. That means that if we try to rely on the picture to use or to observe the properties, we are in some sort of trouble with parallel lines, because who knows what is that? Is that parallel lines, or that's just lines which form very, very sharp angle? If the angle would be 1 degree, we never will distinguish it by an eye from parallel lines. So this is formally like doable thing. So you just say that here that BC is parallel to AD. But actually, this is, of course, some side note. It's not part of the picture. But rather than that, we have this opportunity. So we may use basic properties which are translatable, which are translatable to relations between angles and segments. And this is quite cool thing. So like, I believe that even up to 80% of those who are competing in mathematics on, say, regional and national level, they would be not capable of doing this. They just don't realize that they should do this. So sometimes they would be doing something similar to this, but they don't understand the full scheme or the full method here. So what does it mean? That means that if we have parallel lines here, that is not just our possibility to denote that these angles are equal, right? It is true that they are equal. But also, we have this basic property of parallel lines that if we have two parallel lines and a section line, then we have the entire story about like equal or complementary angles here. I would say we have just thing about angles. So this property, this pattern is sort of translatable to the language of angles or to notations in angles as soon as it appears somewhere on the picture. And here that means that we have not just the property of parallel lines. We have relation between two parallel lines and a section line, which actually suggests that for every section line, we better denote some equality of angles, because that would be specifying their relation. So instead of just drawing those angles which I denoted in the beginning, like me personally, as a geometry person, I would be doing the following. I would be looking an opportunity to denote these angles for every occasion of parallel lines and a section line, which makes rather more information here. It may be overwhelming that we have 5 section lines, and like, do we need to denote all of them or like something? But at the beginning, for the draft of the picture, that is exactly what we need to do. So here, an important thing is to have this understanding that we start from draft. And that is exactly what I would miss if I do conventional lecture here. So I would draw just the good picture. If I would be absolutely not understanding how geometry is done, I would use some special tool so that my picture is like perfect. I would use GeoGebra or something else, and I draw in front of you just the final perfect picture, preliminary prepared, which you never can do when you meet a new problem in geometry, right? So that means that like I would have this perfect picture, I would have just necessary angles denoted, and that is how you will believe the problem is solved. But there would be huge misconception. It would be the final result of the entire process of solution. And that is completely different thing from solving the problem, right? So if you want to study how to solve a problem rather than how to understand the solution which is told to you, you should do some other things. So here, what you should do if you want to solve the problem, you should use all the instances of such pattern, two parallel lines and section line, and at least consider it if you need to bring it to the picture or not. So here that will give you also like a push towards denoting these angles. What else? Probably these angles. These angles. And what? And these angles. Of course, I'm now telling this in some slow manner. And but you do that on like in your practice, in your own practice, you do that rather faster. You just do the notation without saying these theoretical words all the time. And this would be my first draft. So this is what I will be using as the first draft. And I always would be accounting for drawing 2 or 3 or even more pictures if I do geometry, because the first picture is supposed to be always incorrect. It must have some imperfections. Otherwise, you should realize that if it's perfect from the first time, you should realize that either it's just not a picture or like not a problem, it's just some very, very, very basic exercise with very few objects involved. Or you just spend too much effort from the very beginning for drawing the very first picture without guarantee that you succeed. Because when you draw the first picture, you never have the guarantee that there will be some very, very special condition in the end, like the phrase like provided that this segment equals to this segment, prove something. So you may study some very special condition in the very end. That means that you never have the guarantee that your first picture would be drawn correctly, because you must have already the entire thing, almost entire picture when you approach the last sentence, right? So from this point of view, when you approach the last sentence may screw up all you draw before. So that means that no guarantee that first picture is good enough. That means that first picture is always, must always be considered as the draft picture. And now, this is the first picture. So second picture here would be not much different, but it would be already a bit different, right? So I understand that I will probably need the angles here. Also, I understand that here, A, B, C, E, I just see that it would be a parallelogram. So I probably should rather draw that as parallelogram instead of drawing somehow. This shouldn't be equal to that side. So in principle, my second picture would be drawn like this. And just now the mathematics will start for me. So now when transiting from the previous picture to the next picture, I may be curious already, what to do here, to solve to solve the problem. And I can see that I'm lucky enough to have many angles here. So from this point of view, I may find out that I may already do some notes. A, B, C, E would be parallelogram. Many equal angles. Maybe we have similar triangles. And now I can start noticing something about the noticing that this is parallelogram. I might just do this additional notation here, that these are equal. Probably I'll be interested in proving the property somewhere, but that is quite straightforward. As for now, I just recall that, okay, that is because of the property of parallelogram, that a quadrilateral with two parallel and equal opposite sides is a parallelogram. So I remember how to prove that. I don't spend time for writing that down at the moment. And about similar triangles here, I try to transit some reasonable angles here. So what reasonable angles may arise here for using these similarities? Obvious similarity would be that triangle BOC is similar to a triangle DOA, right? So we have these two triangles having these angles vertical. Also, we have vertical angles here. And in these two triangles, we have just the same set of angles already denoted. So even by two angles, we can recognize that those would be similar. These two triangles, they involve the important segments BC and AD, but they don't involve the segments which are provided to us in the condition, BO and PD. So we need something else, right? Otherwise, if we don't use the conditions on BO and PD, we probably must have this as a common property just for any trapezoid, which is a bit ridiculous to expect. Like trapezoid is very common object. If it would be true, this short statement about the bases, of course, should be well known to us. Like also we can check easily, but more strictly that it cannot hold for any AB and BC. For example, we can factor out coefficient BC, common factor BC, that would be BC times BC plus AD. So we can see that first of all, it's not very likely that for arbitrary BC and AD it holds, but also we can see that if we, for example, increase BC, then at some moment, like when BC, if BC would be greater than AD, for example, it already makes no sense, like this part would be greater. So we must use these additional conditions. No, actually, we used BO here, but we didn't use PD, right? BO was part of this. So we didn't use the equality between this or anything compared to that. So we must to have some additional conditions on PD. So let's try to find something on PD that would be, for example, from this triangle, PDE, it is similar to triangle PBC. So from this similarity, we will have some conditions on the sides PD, BC, and like also something about diagonal BD, right? Because it will be on BP and PD. Any obvious similarities, additional similarities so far? So this and this. So it doesn't look like we have much more, right? Yeah. So I will do following. I will write down the next level of writing down these similarities. So that would be naturally the way how I solve geometry. So first we had I drew the picture, right? Then I redrew the picture and started doing some notices because they became very straightforward. And now I have the possibility to write down some very precise consequences from this. So here probably I would denote the necessary angles before I move to the next step. So here would be OP. We also use these angles, these and these. Probably nothing else. Actually, I can notice one more thing which is not used here. So I wonder how I could use this property that A, B, C, E is a parallelogram. So in order to like shorten the thing a bit, so here I had this, like it would be already a bit of a trick. So that is how I would try to use parallelogram here. No, sorry. Like, let me first, like that would be actually the next iteration. So the very straightforward iteration here is that from these similarities, I would immediately write down that just by following the order of vertices, like as I wrote the similar triangles in a corresponding order, now I can write down this condition metrically for the sides in very technical manner. I just use the letters here without using the picture already. So I can say that there it would be double equality. BO to over DO would be equal to BC over DA, would be equal to OC over OA. So that is how I just unshell, like as I open this similarity metrically. So as the vertices follow in corresponding order, I can see that BO corresponds to DO, and say OC corresponds to OA, and of course BC corresponds to DA then. So that is how I rewrite this. And also I will rewrite the second one as well. So PD over PB would be equal to PE over PC would be equal to DE over BC. That would be 2 stars. Here, it would be quite useful to notice what did we use from the data which we have in the conditions. So we have this BC, which is of our interest, BO of our interest, maybe DO, or AOC, DA. DA is part of our equation, which we like equality, which we should show. PD probably is the part of this because it's on this line with like no, PD is definitely of our interest because it's, as for now, it's only additional relation for the segment DP or PD. So we must use it somehow so that we use the starting condition. PB probably may be used. PE, not sure. PC, like who knows. DE and BC. So DE probably, BC definitely. So we have now sort of map of what is important for us, what is less important for us, and we can see that here we have already less interest in fractions. Like we may practice a bit with that. And like another thing to notice here actually, so most likely it would be not enough to prove the problem, but what we may notice and use here is that we also have equality of this angle and this angle because of the parallel thing, because of the parallelogram. Then actually to approach PD in some other manner, but we can find also other similarity that DP. So actually that is like using these CE and BA as parallel lines at the moment. So I used the same principle, trying to denote on the picture the property of our interest, but for these two parallel lines. So I can see that DPE would be similar to DBA. This is first. And also in a similar manner, we can use this equality of angles. So now I'm shortcutting already a bit. So like we can spend even more time for this problem, but I want to show you one really difficult problem today as well. And we have still not that much time. So that's why I just denote this, but it also may take some time to you to realize that if you apply these principles and you notice that we have parallelogram, we must sort of apply the same principles of drawing to the another two parallel lines. So from there we have this similarity DPE similar to DBA, not to confuse the order of vertices, otherwise it would be very, very bad present to ourselves. And we have this another similarity here, that ABO is similar to triangle ABO, ABO, CPO. So we also may write down these conditions. My claim is that these four double equalities is enough to solve the problem. So just picking up the correct ratios and probably doing some arithmetics related to the fact that AE that AE plus ED equals to AD, that would be enough. And AE equal to BC. That would be enough for solving the problem, for establishing the equality. But this, I will remind you as a part of home task. So this really becomes a technical exercise. So this you rewrite as fractions. Then you have a bit excessive amount of equalities and of fractions, but still, it's nothing compared to some problems on IMO. So it shouldn't frighten you, and you should choose whatever you need to a problem to solve it, even though other people may consider the problem simple. If you need some more complex things, you never should be shy to use them. That is your responsibility, and that would be your result, right? If you don't take the result because you was shy to use some specific or special technique which you know how to use, that is your responsibility to to experience the consequences, right? That you underscore something. So please finish this at home, and I want to discuss one other problem as well. So that we do today not just elementary problems, but complex ones as well. So that was the last of problems from the list. Probably I also will not give the full solution today, but I will give you some hints how to approach this. And you will have some time to try to do that before, and some substantial time here, right? It would be a bit crazy to expect from you to have huge progress in IMO problem if you have 10 minutes, right? You may have, but I may not expect that. So here I would do a faster reading, and all the things I would do faster here, like to start to come to the mathematics. So let gamma be the circle of acute triangle ABC. So I start from circle because in this order it's easier to draw. So I have this picture, ABC, points D and E on segments A. Sorry guys, like any questions about the first part, about this problem and the steps leading us to this point? Okay, like seems like no urgent questions at least. So like if you will have some questions, like let me know on WhatsApp. Also, of course, like don't expect me to react immediately on WhatsApp. Like in principle, of course, not always I'm just available. Like I will react as soon as I can, but also like I have rather more reasons not to react immediately when we are in class, because oftentimes I'll be telling something, right? So if you need my immediate or about to immediate reaction, please let me know somehow else. For example, writing to WhatsApp the sense and letting me know on chat of Zoom that you wrote me something on WhatsApp, which is urgent. I expect no urgent things as for now. So we have this picture as for now. Points D and E are on segments A, B, and AC. So D and E on A, B, and AC. Just one sec. I already have a picture. I want these two. Yeah. So we have D and E over here on these sides. I don't know the preliminary. No, I know some preliminary conditions, so I just denote that this would be. I will try to mimic the process of doing that on paper. So as it is draft picture, I denote like this. AD equals to AE. The perpendicular bisectors of BD and CE, so BD and CE. One and another one. Perpendicular bisector is an object which is denoted by two its core properties, equal parts of the segment and right angle. So these two perpendicular bisectors intersect minor arcs AB and AC. It may be a bit ambiguous condition about minor arc. So in principle, if we see such sentence, we should pay a bit more attention. But in principle, here it would mean that intersections external to the triangle, like to the side which is external to the triangle. So here, BD and CE intersects minor arcs AB and AC of gamma at points F and G respectively. If you confuse something in such phrase, you should know that the phrase may be simplified just by picking up the corresponding pieces of data. So the perpendicular bisector of BD intersect minor arc AB of gamma at point F, right? BD, the perpendicular, intersects minor arc AB, it's here, at point F. And the similar construction, same type construction, would be to the for the another side. So here we will have G. This part we can do faster. Prove that lines DE and FG, DEF is here. FG is here. Are either parallel or they are the same line. Okay. What we can notice first, denote on the next stage, on the next drawing, and what we can expect in principle. So, of course, I would denote some basic things here. So this angle equals to this angle. Also, if speaking of that principle that we denote relation through corresponding visual properties, angles or segments, I can say that this perpendicular bisector or point F, it may be described in some systematic way with use of auxiliary segments. So we may draw FD and FB. They must be equal to each other. And also same thing about the point G. So these guys are also equal. This also leads us to some angle consideration. So we can say that this angle would be equal to this angle. This angle would be equal to this angle. What else? And we should show that these two guys, they are parallel. Because the condition that they are same line is, of course, just condition that they are parallel as lines, which are taking the same position on the picture. To say the truth, I have no huge suggestion for this, so I just cannot see any very transparent way to denote this. So first of all, I need to use different notation for these angles. So I expect them to be parallel. So I give similar notations, but different because I don't know that for sure as for now. That is a reminder for me that I want to show that. But also, it doesn't look like I would use this property, right? Seems like I need to find better translation to graphical language, because in this trapezoid to be like in this quadrilateral, which I expect to be trapezoid, it's not very realistic that I will easily access this angle. So probably I will be using some other sort of angles. So that is to figure out. So now I'm supposed to redraw the picture. But what I can see here is that the angles here, for example, on this, like at these triangles, it's not very clear how to approach these angles. This angle, for example, FBA, it's still something which may be somehow approachable through the arc here. But the arc is defined with one standard point A and one very non-standard point, which is maybe you don't have this intuition, but like I have this intuition that I never saw such point F, and I never saw reasonable ways how to approach an arc which is cut with a segment and perpendicular at some random point. Because like what we do here, we consider all possible points here. So this would be in some sense just random points on arc here. So it's very non-standard feature of the problem. So I understand that I'm not expecting myself to access this problem through just drawing the angles. That is the point. And I expect you to know this drawing the angles to some extent. So this is already a new layer. So what I will do now, I will try play with choice of these arbitrary points D and E. So this may be called perturbation of the construction by free choice of the point D. So the point, depending on the choice of point D or point E, which is quite same here, we will have a different situation each time. And this situation, if you try to play with it, it will be already not already, it would be quite troublesome to approach. Like, as to me, it was quite not clear what to do with the problem for some substantial time. But what I may do, I may try to get a bit more insights on the situation if I try considering different positions of E and the way how the picture changes. So instead of considering this picture, the property itself, it should be true for all possible positions of E. So I can sort of informally see and probably even formally prove that that the motion of the construction would be continuous through the continuous on the choice of E. So if I move E continuously, the picture would move continuously. And you can imagine that in some reasonable way. So I shift E a bit, then D would be shifted correspondingly. Like the perpendicular bisectors would be shifted also slightly, corresponding to the shift of E. So everything will be shifted a bit. And the line would change the position as well. What I can see that direction of DE wouldn't change because it would be still perpendicular to the bisector, angular bisector of A. That is some side note, but not that clear, like anything but that. So the line would shift a bit, and if the problem is true, the shift should be done in parallel manner. And that is everything we understand at the moment. So what I will try to do is to try to keep track of this situation. So I will make some special choice of points D and E. So we have this A, B, C, and I will consider E at the point C. By this principle of continuity, of continuum movement, we can realize that when approaching to C, everything but the perpendicular bisector to segment CE would move, like it would just remain as it was defined. And here, for the perpendicular bisector of CE, we can just see that point G is also continuously moving, and the end of the continuous move would be the point C. So I expect G to be degenerated or to approach the position of C, and then the picture would be simplified probably by much. So we have just this situation that D is a point on the segment AB, so that AC equals to AD. And the rest of the construction is just same. So we have this straight line DC. We have the perpendicular bisector to the segment DB. Which I don't expect to get much use on this side. So I will just remain in this manner. So this would be point, what's that? Point F then. And so if E goes to C, then G goes also to C, and FG goes to FC. So here, we need to prove that DC would be parallel to FG. So this would be the degenerate case of this problem, which we'll be considering like if we can solve the general case, this degenerate case also should be covered with that with that reasoning. That is the idea. So that is why I drew instead of just general case here, I ended up in redrawing the picture in some degenerate case, right? Speaking of like the traditional approach in school, I would say that this probably makes not much sense, because the main remark here would be that, okay, but this is different problem. Like this is just partial case. It wouldn't prove the entire thing. Of course, with all respect, I understand that it wouldn't solve the entire case, but we have no advances at the moment at the problem. And like this would be done by me probably in, I don't know, in 10-15 minutes of solving the problem and realizing that I have no good understanding of what's happening there. That would be the reason. Now I just need to shortcut. So I draw this expecting that this would be more simple situation, because a couple of points, they degenerated to some to the same point and to same well-known point, the vertex of the problem. But this would be, then this condition would be that DC is parallel not to FG but FC, right? As G is coinciding with C. So here in this degenerate case, that would be proving that DC is parallel to FC. Like I use some special notation for the word proof. It's just exclamation mark in parentheses. This stands for proof. So it's equivalent to proving that DC is parallel to FC. But this would be then two parallel lines sharing the same point, which would be equivalent to proving that F, D, and C belong to a straight line. So it actually turns out that in this degenerate case, we have rather more understandable construction. Instead of dealing with one understandable line, which is here just, what is that? That is just a perpendicular line to the angular bisector of this angle, right? So as this would be an equilateral triangle, it would be also a height, the bisector, angular bisector would be also height of this angle, but the angular bisector would be stable part of the drawing. It is not affected by shifting the points D and E. So that is actually one of the ways how to parameterize this segment DE. So what? So instead of having one understandable object, DC, and one completely not clear object, FG, we will have like some half understandable situation. So we have points C, D, F, which we want to put to the same line. And then actually what normally happens to such complicated questions as problems from IMO, it's worthwhile redrawing again. So now I have the following situation. I understand how to describe this segment DC better now. So I do the auxiliary element first. Now I understand that to draw that properly, I just need to draw the perpendicular. So I have this part. I then expect to have the continuation of the segment to here. And here, the definition itself of the point, like here. So this is my drawing at the moment. A, D, B, C. So I have this situation and some notations. So actually now I have some approach how to understand what's happening here. Like here, like we realize, like this triangle I denoted it was equilateral. This triangle also equilateral. That's the reason to draw these angles. And now what I must do in order to show that this is straight line, if this is straight line, then by the properties of the circle, we must have that this angle here would be equal to, like, the green angle should be equal to the blue angle, right? The simple green arc angle here, which is also this angle, must be equal to this, if this is really a straight line. And if it is true, we can easily observe that that is another way how to show that this is straight line. Because if we have this angle equal to this angle, without knowing that these three guys lie on the same straight line, we just continue this straight line to the intersection point, and have that if the continuation doesn't coincide with this like segment, then we have two different points. This angle, which would be watching to the same arc here, should be equal to this angle. And this would be, by the equality, equal to this angle, which would be corresponding to the arc from the vertex to the intersection, this intersection. So we will have that two arcs must be equal if the two angles are equal. But as they start at the same point A and go in the same direction, if they are equal, they must end in the same point. So that would be our method how to prove that if these two angles are equal to each other, then these three guys belong to the same straight line. And this is something to prove. So we sort of reduced enough to prove that angle ACD equals to angle ABF. And this is already some angular, realizable, and reasonable condition, right? So probably it's not simple still. We don't observe that as for now, but it is it may be doable in some classical form, and it will be doable in some classical form. So I also want to remain the problem in this form to you, to your consideration. So this becomes like another problem to prove. It still doesn't prove the initial problem, like on the previous page. You will have another, like even if you do this part, you will have another complementary part, like to prove that when we shift the line CD towards A, why the shifted line FG will be still parallel to the same direction. But that will be, that this remaining part will be more reasonable after proving this part. Probably also you will have some insights on that. But also that would be like another nice problem to solve. So technically we divided the initial problem into two different problems by this shifting of the segment DC and considering special position of C or starting position of C instead of arbitrary position of C. By this, I want to finish the starting lecture, the starting class. Today was like establishing class. I saw some of your reactions on the problems. I saw like how fast you are in solving those problems about similarity of triangles. So I needed that to understand more, to understand better what is meant when they say that like you have some troubles with geometry. But the rest I want like to do after I see how you try to continue this. Just one sec. Sorry guys, one sec. So I will send you list of problems, and these would be two poles of that list. You will have problems similar to the first two. You will have problems related to this one, like the two which I mentioned, and probably some others which you may use as hints to this. There would be at least one classical problem related to this about external angular bisector, which is related to this picture. And also you will have some minor block of intermediate problems. They may be slightly disattached to both poles, but the idea would be that today we touched and we started a big topic of how we organize geometrical thinking. It's not about some particular topic. It's about organization of our job, of our work as a mathematician when we do geometry. So we started the initial point, like it, I don't know how for you, but for me, it makes not much sense if we discuss in many details the overall process, but we don't discuss the starting part of the process, even though it's simple. So that's why we discussed in many details the starting part. And also we touched very professional part already when we not just redraw, but when we redraw the picture in with some special circumstances or additional limitations. So we first realize how to draw that, and then we decide that we want to draw not the general case, but we want to draw some more specific case. And there would be an intermediate, like in theory, there was supposed an intermediate part when you have some like couple of special techniques of proving when you shift elements just slightly. That is oftentimes that would be oftentimes used when you need to prove equivalence of some properties. When you have problem like prove that something is hold if and only if some other condition is hold. So sometimes these statements would be easily proved in one direction, and in other direction that they would be just like barely solvable, like really difficult to solve in opposite direction. And then some minor shift of a point or of part of the picture may also be very helpful. So when you notice that you can do half of the problem, you eventually may realize technically by just shifting the picture, the drawing, that you are still able to show that the opposite, I would say, cannot fail. So you will use proof by contradiction there, and you don't prove directly, but you show that the property cannot fail, which is also valid mathematical proof, right? Like we do that all the time in other parts of mathematics. So here we can get use of proof by contradiction as well. Okay, that's it. Any questions? No questions as for now. Don't be afraid if you understand not that much, though you have image that everything in particular was very simple, like that you cannot solve the problems or you cannot solve the problems in the way like I suggest them. Just stay in the process. Do your best to progress as far as you can. And then the progress will come. Wait for the rest of the problems, and like actually don't wait for the rest of the problems. Try solving as many problems as you can right now. You can do the screenshot if you want, and later on I will send the text. And also I will send the slides. and you will have the video. Okay, if no questions now, you may ask them later, and I say goodbye for now. So see you next time.
See you next
See you.
time. Thank
Thank
you.
you.
Welcome. Bye.
Bye.